Welcome to the next video. This video is on solving inequalities algebraically. Now, before we talk about solving inequalities, let's talk a little bit about absolute values, because that's going to play a part in this section. Now, as a reminder, absolute value is defined to be the distance away from zero. So you have absolute value of A equals the distance that A is away from zero, or the origin. Now, A itself could be a positive number. For example, A could be positive 2. What is the distance that 2 is away from 0? It's 2. But A could also itself be a negative number. For example, the absolute value of negative 7. How far away is negative 7 from 0? Well, it's 7 units away. By definition, then, the absolute value of a number or an expression always needs to be a positive number or 0. Okay, so now we're ready to do an example that has absolute values in it. That's an inequality. So, first, before that though, what does it mean if I say the absolute value of A is less than C? Well, what that means is that the value of A needs to be C units within C units from 0. So, if I have C over here and I have negative C over here, then A needs to be in this red region, this pink region, because that region contains values that are within C units from 0. So algebraically, how does that look like? Well, that is going to look like this. A is between C and negative C. As you can see, A is sandwiched between negative C and C, which matches this picture pretty well, right? This picture visually shows that I'm sandwiched between negative C and C. And so this A is also trapped between negative C and C. So let's do an example. Example 1. We have the absolute value of 2x plus 3 is less than 15. Well, what does that mean? It means that 2x plus 3 has to be trapped between 15 and negative 15, because that's what it means for the expression 2x plus 3 to be within 15 units away from 0. Now that you have that set up, all you have to do is get x by itself. So the first step is to subtract 3 on every term. So we subtract 3 on every term, and what we end up getting, and I'm going to move it over here, is negative 18 is less than 2x is less than 12. Then the last thing that remains to be done is to divide everything by 2. So your final answer is negative 9 is less than x is less than 6. Now, what if we have absolute value of A is greater than C? Let's see what will happen. First, let's get rid of this work right here. Again, if you didn't get to write all this down, you can always rewind the video. Okay, so now we're working with, what if we have absolute value of A is greater than C? Well, by definition, what that means is that A has to be more than C units away from 0. Graphically, if this is 0, then to be more than C units away, you need to be either greater than C or less than negative C. So the algebraic way to write this is A is greater than C or A is less than negative C. Notice we have to write it separate like that because on the graph there are two separate regions. So let's do an example. Example 2. Example 2 will be the absolute value of 4 minus 3x is greater than or equal to 10. So following the rule above, we have 4 minus 3x is greater than or equal to 10, or we have 4 minus 3x is less than or equal to negative 10. Let's see this graphically. Here is 10, here is negative 10. So the expression that is inside the absolute value needs to be either over here, where it's greater than 10, or over here, where it's less than negative 10. That's the only way that you can be more than 10 units away from 0. So now that we have these set up, we are going to just solve them as if they're two separate inequalities. This one becomes negative 3x is greater than or equal to 6. So x is less than or equal to negative 2. Notice here that I switched the signs because I divided both sides by a negative number, namely negative 3. Over here, I do the same thing. Negative x is less than or equal to negative 14. So x is greater than or equal to 14 over 3. Again, we had to do that. We had to switch the sign because we divided both sides by a negative. Just put an or in between, and this right here is your answer. Okay, pretty simple. Now we have one more type of question to cover. So let me get rid of this now. The last type of question has to do with a quadratic within an inequality. So the best way to talk about this is to just start off with an example. Let's say I have x squared plus 4x minus 5 is less than 0. Now, whenever you have a quadratic in an inequality, you want to first factor the quadratic. So you have x plus 5, x minus 1 is less than 0. Now, this next part is very important that you understand the concept behind this so that what you do will make sense to you. Whenever you have two things multiplied by each other, the whole result will be positive if both the factors are positive or if both the factors are negative. When you multiply two things, the result will be negative when one of the factors is positive and one of the factors is negative. So what we have to do is to find a way to figure out when will both parentheses be positive, when will both parentheses be negative, and when will it be the case where one is negative and the other one is positive. So there are some ways to organize this. I'm going to show you two ways to organize this. The first way is to make a table. So I'm going to make a table. This first one is to write our interval. This next one is to write the first factor. The second factor is the third column, and then the result, like this. Okay. Now, what are our intervals? How do we get our intervals? Well, the intervals will be separated by what we call transition points. And transition points are x values that make each of the two parentheses 0. So what makes x plus 5 0? It would be negative 5. What makes x minus 1 0? That's when x is 1. So we break our interval up in these three intervals. X is less than negative 5. X is between negative 5 and 1. And x is greater than 1. So then we test values. We pick a value that is in this first interval, like x being negative 10. If we did that, negative 10 plus 5 is negative. Negative 10 minus 1 is negative. So x plus 5 times x minus 1 would be positive because negative times a negative is a positive. In this second interval, right here, let's choose an easy number to work with, like 0. Well, 0 plus 5 is positive. 0 minus 1 is negative. Positive times a negative is negative. Third interval. What would be a good number to plug in for this? Well, I can choose any number that's greater than 1, so I'll choose 3. 3 plus 5 is positive. 3 minus 1 is positive. So positive times positive is positive. Now looking back at our original problem, we want our result to be less than 0. So that means that what we want is this middle case right over here, because that's when the final result is negative. So our answer is going to be negative 5 is less than x is less than 1. There's our answer. Okay? Now another way to organize this is a little simpler, and some of you guys might prefer this. So I'll write it in pink in this corner. It is simply to draw a number line like this and to plot the transition points onto the number line. Notice that we have broken ourselves into 3 intervals, what I call Roman numeral 1, Roman numeral 2, and Roman numeral 3. If I pick a number in Roman numeral 1, like negative 6, and I plug it into my expression, I will quickly find out that this will be positive. If I pick a number between negative 5 and 1 in interval 2, and I plug that number like 0 into the expression, I'll get negative. And then if I pick a number from interval 3 and plug it into the original inequality, I get positive. So that tells me that where I want to be is interval 2. So you can use either organizational method to do these problems. Okay? Now to end, I want you to practice with a couple problems. So include these problems on your notes. Okay? So I'm about to write them down. I'm going to delete what we have here. Once again, if you missed something, just rewind the video. Okay, almost done here. Just need to find a faster way to get rid of stuff next time. Okay, here are the examples I want you to try on your own in your notes. First one, absolute value of 6x plus 1 is less than 18. Number 2, 12 minus x is greater than or equal to 5. Number 3, x squared plus 2x minus 8 is greater than or equal to 0. And number 4, 3x squared minus x minus 10 less than 0. Try your best to try those problems using the method that I just showed you, and make sure that you have them ready for class tomorrow. See you guys all in class.